I'm going to change my camera rather than use two cameras. And I have to take the blur off. Okay. Can y'all see at all? This
Yeah,
page?
I can see.
It might help to pin it. I don't know. There are three dots at the top of the square for everything. Whoa, what color is that? Not. Just a sec. Let me figure out colors. Uh, but there are three dots, and if you I think I'm making it worse. Wait, maybe. Well, that's still black and white. Um, if you click the three dots, there should be an option to set it as a pinned thing, and then I think you'll be able to see it better. Okay. Zoom, zoom, rotate, filter, light. Color. Okay, now let's get focused. Can y'all see that at all? It's not in focus, is it?
I can kind of see it.
Kind does not.
I think it's too
I mean,
close.
okay, let's
It's
see.
pretty blurry.
Yeah, it is pretty blurry. Okay, let's see. Come back. Here. Okay. See if we can get it to focus here. No, golly darn.
Just focus on your hand.
Yeah, I'm trying to leave my hand out of the camera's view. Usually this camera is very good. Oh heck. Um oh, I just don't know. I tell you what, I'm gonna write on paper and see if I can write large enough that it's legible. Can somebody tell Jaden to sign in, please? It's not even really focusing on, oh, now it is. It's focusing on the pens. Okay.
What's up, miss? You good?
Uh, I'm better now that you're here, but yeah, I don't know.
Amen.
Okay, the formal definition of continuity. Is that large enough that you can read it even though it's not in focus?
Yeah.
Yep.
I don't know what's up with my camera. Okay. We need three things. One, we need, or the definition of continuity of function f of x at x equals c. We need f of a c to exist. We need the limit as x approaches c of f of x to exist. And then third, we put these together. We need f of c to equal the limit as x approaches c of f of x. Golly. Let me play with the camera just a bit. Wonder if it needs more light. Oh, come on. There we go. There we go. Well, this seems not to be working either. That's okay. Okay, let's see if this will enable it to focus. Is that any better? Can you all
It's big
read
enough
that?
to read.
Okay, all right. Oh, this kind of sucks.
Looks
But
pretty good,
I mean,
miss.
thank you.
I think it's focusing on like the can that you have, like besides.
on what on this side, the stuff that I'm moving?
Yeah, I think it was focusing on that.
Okay, let's see. Because I think it's possible that you're right. I just don't know how to force it. Oh, come on.
Is the lens clean?
I think so.
Mm.
You know, Jaden, I couldn't tell you honestly.
It's really, I can read it.
Pardon?
It's not that bad. I can read it.
All right. Thanks. So this is a definition that's similar to what we used before. Well, earlier we said if the limit from the left equaled the function value equaled the limit from the right, then we had continuity. And what this does is it breaks that down into three parts. So first, we must have C in the domain of the function, and f of c therefore has to exist. Also, when it says that the limit as x approaches c of f of x exists, that means it exists, it equals some L, and that L is not infinity. And then we get the part that we saw before. So let's look at an example. And then we'll, in the process of this example, I'm going to look at the at the discontinuities that we can face. So this is example 2. I have f of x is equal to x minus 3 if x is less than 4, 2 if x equals 4, and
Miss,
yeah,
isn't that the try this 2A?
I took away the try this 2A and y'all are gonna do the try this 2B with a little change. But
Oh,
yes, this is very similar to the try this 2A.
oh,
Thank you. Thanks, Lily. So we have 3 parts of f of x, and every part is, well, the 2 big parts are straight lines. If x is below 4, we use f of x equals x minus 3. If x is above 4, we use f of x equals 2x minus 7. And right at 4, we use x equals 2. And I'm going to try something. I want to use excuse me. I want to try to use I want to try to use Desmos to show y'all what this looks like. What do you see? Like, do you see Wolfram Math World?
yes.
Okay, groovy. So I want to show y'all how to enter a function like this. We said that I'm going to use y instead of f of x just for simplicity. So I said y equals x minus 3 and it looks like x minus 3 is going to take up the whole screen, but I don't want it to. I want it only to be used when x is below 4. So I'm going to put braces, and inside those braces, I'm going to put x less than 4. And I want to add a little bit more detail to the graph. To control what the graph looks like, I'm going to go into this wrench. I definitely want to see every single, is that easier to read? Can y'all see that graph?
Yes.
Okay, groovy.
Yes.
Yep.
Oh, I don't know why I put T. That should have been a Y. And then Y is equal to 2x minus 7. And I'm going to, again, I just spaced one space over, and I'm putting braces. And within those braces, I'm going to put x is greater than 4. And now we have the point 4, 2. And I can do one more thing at 4 comma 1. I want it open. So I just long pressed on the color, and that enabled me to choose the type of hole. So here we've got F, and I'm going to make it a little bit bigger. All right, but that's not, let's see. I'm going to make everything bigger. 15. 15. All right. So now, is f of x continuous? If this whole thing is f of x, the red line, the blue line, and the green dot
It's
is
not
f of x. Yes, exactly right. And we call this a removable discontinuity because the only discontinuity is in the form of a hole. So we have a hole or removable discontinuity. And what we can do if we have a hole or a removable discontinuity is that we can fix f of x. And this is what we're going to do. We're going to define capital F of x, and it's going to equal little f of x everywhere except the discontinuity. So capital F of x is going to equal little f of x as long as x isn't 4. And we're going to define f of 4 to be the limit that we got on the others. So f of 4 here will be 1. So it looks like this. Capital F of x is equal to little f of x if x isn't 4, and it's equal to 1 if x is 4. Make sure everybody to sign in. Can you try to zoom in? Maybe it will. Oh, yeah, let's try that. It's too much. That's better though, huh?
Yeah, that looks better.
Okay, good. There's Isaac. All right, great. So let's go back to the drawing. We would say that capital F of x equals, let's do this. So I'm defining, oh, and that should be an X. I'm defining F1 to be this left leg, F2 to be the right leg, and then we've got the point 4, 2, so that f of x, capital F of x, is equal to one of x and I'm going to put x is less than 4 it'll equal f2 of x if x is greater than 4 and f of 4 f of 4 is equal to 1. And they don't like me using that notation, so I just use the 0.41. And you can see that all we've done is take this point of discontinuity and paste it down. So I want y'all, let's see if this can be in focus now too a little bit. Let's go closer. Go the other way. Okay. So I made try this, I combined the try this 2A and 2B. So that part of it was the example that we just did, and part of it is this example. So I want y'all to determine whether or not g of x, well, first graph g of x. So if x is below 9, which part of the function do you use?
The first one, x minus 8.
Good, thanks. If x is above 9,
The
Use
third
the-
one.
Yeah.
good. And then if x equals 9,
Use
2.
2.
good. So these are both straight lines, should be pretty easy to graph. And let's see if you can upload a graph, upload a photo of a graph into the chat. So the way I'd like to work this is I'm gonna be here, but I'm gonna turn my audio off, and I want y'all to talk, please. A little bit louder.
What are we talking
I'm still
about?
So how are you going to graph this function?
Oh,
That's the first thing.
like we would with our
plug in
groups.
something.
Yeah.
Okay.
And then does it have a discontinuity? And if it's that kind that we just saw with the hole, we haven't used the names of the other kinds, but if it has a hole discontinuity, then fix G.
Okay.
So I guess the graph, we'll go to x minus 8. Um, it's just a normal diagonal line, a one-to-one function. Here, for everything less than 9. And at 9 will be 2x minus 17. X was 9, 18, minus 17 is 1.
How you guys get the open again on Desmos?
We're using Desmond.
I mean, I use Desmos just for the graphing.
I'll show you just a sec. Do you see the graph?
Yeah.
So let's take this away. If I have a point I want to include, but I want that point to be open, then I'm just going to press on that color. So the dot in the color, I'm going to press until this screen comes up, and then I'm going to choose this circle.
Okay.
And it actually does a nice job. Going away again.
I think I got the graph, but we have to like try to figure out the discontinuity, right?
Yeah. Well, it would be, I guess, an open circle up until for the first section of it until 9.
Yeah.
Okay. Yeah, I guess it would continue. Yeah, because at 9 in the first half, it's still covered by the second function. So it would be all real numbers, right?
Yes.
It'll be all the numbers.
More or
Yeah.
less.
It's just on the second function, it takes a sharper turn. And the range would be the same. Yeah, all real numbers too.
So did little g of x have a hole?
Yes.
And was it the kind of hole that could be mended? I can't say dim.
No.
It couldn't be fixed.
I thought yes, because it's continuous, right?
Yeah, well, we could just move it down a
So
little.
so let's look at it. I'm gonna share Desmos again. Okay, so the first what is the first part of g of x?
X minus 8, where X is less than 9.
Oh, come on. Pardon my language. Okay, that's all right. X minus 8. And this is for x less than 9. And this is G1. Yeah. And what is the third part of g of x?
Do it. Minus 7, right? Oh, or minus 17.
Yeah. Okay, good. And it's x is greater than 9. And let's go ahead and put the hole in. Actually, let's plot the point. So at 9, what is the value of g?
2.
Okay, good. So since this point isn't on our line, I want to fill in, I want to create a hole. So I'm just going to type in 9, 1 and go in. I'm just going to hold on the color, and that brings up this hole. Okay. And that's too tiny. All right. So this is essentially the same question that we had before. All we have to do for capital G of x is what?
I'm not sure. I think I might have a different page than you.
Yeah, so my where is it? I'm gonna stop sharing for a second. I redid the try this question. I think this was try this 2B, and I added this piece in the middle.
Okay.
So using this function, we can see that we got a hole at x equals 9. Can we create a function capital G that will equal G of x if x isn't 9? What should it equal if x is 9?
2.
1.
1, that's right.
Oh.
Because the limit as x approaches 1 of little g of x is 1. I mean, as x approaches 9 of little g of x is 1. But the definition put the value at 9 to be 2, and we want it to be 1. So you can create functions in this way to paste a value you want onto a function you have without losing any of the important parts of the function that you started with. There are two other, so this is the process of removing a whole discontinuity. Just that you let f of x, capital F of x equal little f of x, except at x equals c, and at x equals c, you let f of c equal L, where L was the limit as x approached c of f, little f of x. There are two other kinds of discontinuities. There's a discontinuity where the limit from the left and the limit from the right are different. And that's called a jump. And we're going to look at one of those in a moment. This kind, the jump discontinuity, is considered somewhat well behaved. The infinite discontinuity is a vertical asymptote, and that is considered essentially discontinuity, it essentially discontinuous. So let's look at those examples. If we have a jump discontinuity, that would be something like this. So here's C. The limit from the left is going up to some y1 value. And the limit from the right maybe it's going to some, it could be a straight line, it could be anything. The key thing is that these values are different. So not only does the function at C have a problem, but the function around C has a problem. The most discontinuous jump discontinuity that exists is this one. F of x equals 1 or 0. It equals 1 if x is rational. And remember, rational just means that it can be written as a fraction. So integers and all fractions, all decimal numbers with terminating decimals or repeating decimals are rational numbers. And it equals 0 if x is irrational. And what's really fun about this is that the graph here's 1. And here's 0. The graph looks like two solid lines, solid horizontal lines. Where I'm using the darker green for the 0 and the lighter green for 1. Because there are infinitely many rational numbers, and there are even more irrational numbers. So this jump discontinuity is the worst jump discontinuity that exists. Is that cool? Just say yes.
Yeah.
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 Y'all are sweet. Okay.
Yes.
And for an asymptotic discontinuity, it's just like you would imagine. it really doesn't matter whether the function goes up on both sides, if this is our value C, down on both sides, up on one side and down on the other. The key is that at least one of the directions is an asymptote. The other could be, it could even be filled in at C and go to the right. If one part is an asymptote, then we would say that this has a vertical discontinuity or an asymptotic discontinuity, and it is essentially discontinuous. The reason that we say a jump discontinuity isn't as bad is that we can, except in the case of a function like the one I just sketched, where it has one value if x is rational and another if it's irrational. We can imagine taking the graph cutting it at C and shifting. So we can imagine cutting this graph at C and shifting it up. So even though algebraically that makes no sense, physically sometimes that does make sense. So this is bad, but not as bad as the asymptotic discontinuity, and the least bad of all is the whole or removable discontinuity. There were two more examples I wanted to look at, and I'm not sure if I can find them. Oh, here they are. This is just practice with reducing interesting looking limits. So if we're trying to find the limit, and let's just look at x equals 2, let's see what the value is. If we just fill in 2, we'll have the square root of 2 times 2 minus 2 divided by 2 times 2 minus 4. What value do we get in the numerator?
Zero.
Good. And in the denominator?
Wouldn't it be 0?
Yes. Almost always, when you get 0 over 0, it means there's a common factor that can be divided out. But it didn't look like this would factor. So let's see. Let's look at the relationship of the values in the numerator and the values in the denominator. What do I have to do to the numerator, to the square root of 2x, to get to 2x?
All right.
Yeah, good. So I'm going to write, let's see, I'm going to write square root of 2x minus 2 divided by, I'm going to write square root of 2x squared. Is that right? Are these the same?
Yes.
Is the square root of 2x? Okay, good. And how are 2 and 4 related?
Factor of 2.
Good. So I'm going to
Or
write,
-2.
well, I'm thinking of the negative as not part of it yet, but I'm going to write this 4 as 2 squared. And now I can see in the denominator, I have the difference of 2 squares. Even though one of the squares has a square root in it, we don't care. So we're going to have the limit as x approaches 2 of the square root of 2x minus 2 over, how would I factor a squared minus b squared?
Then you looked at this before, right?
Say it louder, please.
I found it.
How do we factor the difference of 2 squares?
Isn't x or a squared minus 2ab or something like that?
That's if we had a minus b all squared. Then we would get a squared minus 2ab plus b squared. But if we have a squared minus b squared, how does that factor? We've talked about it in class.
Is it a plus b in parentheses times a minus b?
Perfect. Yes. Was that Nico?
Yes.
Yes. Yay. Exactly right. So we are going to think of the square root of 2x squared minus 2 squared as the difference of 2 squares. And let's factor it just using the rule that we have. Make sure to sign in, everybody. Just put your name in the chat to sign in. So what is a in this in the square root of 2x all squared minus 2 squared? What is a? What is little a?
2x
Squared.
square rooted.
So the square root of 2x?
Yes.
Yeah.
Good. So that'll go in the first spot. And what is b?
2.
Good. That'll go in the second spot. What goes between them?
1 positive, 1 negative.
Very good. Does it matter? Could I put a negative first and a positive second?
Yeah, because multiplying
Yes,
at the
very
end.
good. That's right. Okay, so we've got a factoring for something that didn't look factorable. Because remember, it really did look like 2x minus 4. So it looked like there was a 2 common, but not a difference of 2 squares. So we're writing square root of 2x minus 2 and the product square root of 2x plus 2 square root of 2x minus 2. Because remember, I said whenever you get 0 over 0 for the limit, it means that there's a common factor that you can go back to the beginning and find some common factor that can be divided out. And do we have a common factor?
2x squared minus 2.
Square root of 2x minus 2? Yes.
Yeah.
What's left in the numerator?
1.
Good. Very good. So now we've got the limit as x approaches 2 of 1 over the square root of 2x plus 2. And let's try again. Let's let x equal 2 and see if we still get something horrible like 0 over 0. If I substitute, let's just write it out. I've got 2 times 2 plus 2. So that's 1 over, what is the square root of 2 times 2?
2.
Good. And 2 plus 2?
4.
Beautiful. So far from being undefined, this limit is actually equal to 1/4. I want y'all to do this question. It's unfortunately not as exciting, but I'll come up with a more exciting one. And I hate to do this to y'all, but I'm kind of feeling really horrible. Horribler. That's not a word. Would y'all mind if we called it for today? If we called it good?
Yeah.
Yeah, that'd be
That's
fine.
fine.
Yeah, Miz,
Okay,
if you're
I'm
not
gonna-
feeling well, go lay down.
I'm okay. Thanks.
It's okay, Miss.
I'm not
I'm still not
feeling well,
feeling
but
that well either.
Thank you so much, everybody. I'll make sure to put these 2 questions clearly in the on the page, so that you know what I want you to post.
Okay.
And thank you all.
Thank you.
Bye, Miss Now.
Bye. Have a
Have a great
wonderful
day, Miss.
day.
Bye.
Bye, Professor.
And
Hope
I'll
you feel
see
better.
you for real on Wednesday.
Goodbye. Feel better.
Thank
Bye.
you.
Professor.
Bye. Feel
Bye.
better.
Bye.
Better miss.
Thank you.